Hello everyone. Myself is Mausam Dubey. I am working as a senior technical architect at Kyvos. Uh, Today, we will learn about how to build your own agentic AI with MCP, Model Context Protocol. Before we start the session, I would like to mention that if during the webinar, if you come across any question, please post your question in the Q&A window, and at the end of the session, we'll answer your questions. So without further delay, let's start. So in today's class, we will start with the basics of MCP. What is MCP? Why MCP is needed? What are the primary components of MCP? How does the MCP client and server communicates with each other? How does MCP client authenticates and authorize with MCP server? And finally, we will end the session where with a coding workshop where my colleague Prakhar will walk you through a step-by-step code of how the MCP integration works, wherein he will show you that how I can use the MCP integration to fetch the data from an external data source and use it in my GenAI app to answer the user's question. Okay. So what is MCP? Now, MCP can be best understood by taking an analogy with a USB connector. So similar to, I can use a USB socket or USB connector to connect different devices like keyboard, mouse, hard disk, audio video devices, or device charger for that matter. I can similarly use MCP protocol to fetch data from various data sources uh, from any other data source into my GenAI app to answer the user's question. Okay, but then why MCP is needed? So let's assume we do not have MCP and I am writing multiple GenAI applications. And in my GenAI applications, I need to fetch data from various data sources, be it email, be it from some database system or some file-based system or from a calendar, right? In each of my GenAI application, I will have to write function or a module or a tool, whatever you call it, to fetch the data from respective data source and provide it into my GenAI application. I will have to handle all the nitty-gritties of authenticating with the source system, and I'll have to think about what kind of communication protocol I should use and whatnot, right? So I need to deal with all those details. And let's assume if I'm developing an M GenAI application and I need to fetch data from P data sources, then essentially I would need to write M cross P functions. Right? So after the introduction of the MCP, the picture becomes something like this, where for each of my data source, I can write an MCP server. And now each of my GenAI applications can talk to respective MCP server to fetch the respective data. Here, the M cross P now becomes M plus P. Now let's have a look at the primary components of MCP ecosystem. So as you can see in the third column here, there are different MCP servers mentioned, which the first one is the Kyvos MCP server, then there's a Jira MCP server, there could be a file system MCP server, and then there could be other MCP server. Now the MCP server is responsible for fetching data from the backend server. So in this case, Kyvos MCP server is fetching the data and metadata of Kyvos semantic model from the Kyvos backend server, while the Jira MCP server is responsible for fetching details about the data in the Jira from the Jira backend server. Now, in the second column, you can see there is a GenAI app. The GenAI app in this case is also called as MCP host. This GenAI app has a component which is known as MCP client. Now, this MCP client is responsible for interacting with all of these MCP server to fetch the relevant data and provide it to the GenAI app. The GenAI app can use this data to answer the user's question accordingly. Now let's look at how the MCP client and MCP server communicates with each other. So there are primarily three transport mechanisms that MCP protocol supports. One is STD-IO transport, and second one is the SSE transport, and third one is streamable HTTP. Now, STD-IO transport is generally referred as a local transport. In this transport mechanism, MCP server is launched as a child process of MCP host or a GenAI app, and both of these MCP client and MCP server communicates using the standard input-output streams. Please note that here that the MCP server is launched as a child process. However, MCP server can connect to the backend server, which is running remotely. Right. Now, this kind of transport option is generally ideal for local process communication and trying out a new thing quickly. So generally, it is useful for demo purpose and POC sort of purpose. For production deployment, the other two transport options are recommended. The other two transport options are the remote transport options, which are HTTP based transport options. The basic difference between the SSE and streamable is that SSE requires maintaining constant connection state. Now, this kind of transport mechanism is useful for the servers, which kind of provide the real time updates or real time monitoring of key matrices. For all other normal scenarios, streamable HTTP is a good option. Now, since MCP is a client server architecture, security becomes utmost important, and MCP takes care of security by providing two types of authentication mechanism: basic authentication and OAuth. Basic authentication is a simple authentication mechanism wherein you can provide API key or user credential in the HTTP header itself, while OAuth authentication involves complex authorization flows where multiple to and fro happens between the client and server to exchange the OAuth related information. Obviously, in the basic authentication, security level is low and it is generally not recommended for production deployment. It is useful for, again, for demo and POC kind of purposes. OAuth is recommended for production grade deployments. Uh, Basic authentication is supported in all the three transport mechanisms: STDIO, SSE, and streamable, while OAuth is supported in SSE and streamable options. Uh, with this introduction, I would like to invite my colleague Prakhar for the coding workshop. Prakhar, over to you.
Thank you, Mosam. Your explanation of MCP, its purpose, and transport types made things much clearer to me. And it made and simplified the complex logic into something easy to grasp. Hello, everyone, and welcome to Building Agentic AI with MCP. We'll discuss about the client and server connectivity. Thank you for joining us today. I am Prakhar Mohan Garg, Associate Manager Software Engineer at Kyvos Insights. I have been working with the Model Context Protocol since its open source release. And here at Kyvos, I architect multiple MCP clients and multiple MCP servers to enable seamless integration and communication across our system. I'll be sharing my screen and we'll go through a Google Colab notebook, which we will be converting into a agentic AI. So now, for the next 20 minutes, I'll walk through this Google Colab notebook and we'll see how MCP client connects to MCP server and how an agent or LLM connects or answers a user's query. So here I'll be covering environmental setup and MCP connectivity, how client-server connections work in practice, OAuth authentication flows with the MCP servers, live tool integration, and agent creation, and finally some real-world examples that will help you making your own agentic apps. So let's get started. The first cell in the Google Colab note is the environmental setup. So there are few dependencies we need to set up for our agentic app. The first is model context protocol for client and server. The SDK is provided by the Anthropic, that is open source, available on the GitHub. The another is OpenAI agents. It is a multi-agent framework which is very lightweight, and it is also available on the GitHub as open source. I have also added some utilities that I need to make this collab work. I have already installed these on this runtime before the session was started. So this is the command to install all these packages. Moving on to the next cell, that is configuration. The main configuration is your Open AI API key or any other LLM API key that is you are going to set up. The good practice is to set up it using an environment variable or a secret vault. Here I am using Google Colab secret vault that is fetching my OpenAI key. Another thing to note is that the OpenAI key, once set in the environment, all the packages of OpenAI will automatically read its key from here. I have also set up few servers. So this is a demo server for Kyvos MCP SSE that we will be using today in our session. Let me quickly run these cells. So the next cell is just a utility that is available online. It is just to pretty print the messages in the coding cells that we will be presenting today. The next module is the MCP client. So for MCP client to work, we need certain wrappers on MCP servers that will communicate to those servers. Okay. So as Mosam already discussed, there are three types of MCP servers that are STD-IO, SSE, and streamable. So let's go through the first, the STD-IO. The STD-IO is a local for our machine and it communicates over the standard input-output streams. How it works is that it spawns a MCP server as a child process. Communications happen through a JCP RPC 2.0 message, and each message is delimited by new line. Here I have imported a package agents MCP and its wrapper MCP server STD-IO. The MCP server STD-IO takes a name. It can be a human-friendly name that can be readable and traceable. It takes params. The param should be whatever the MCP server you are trying to use, its command has to be going here. So I'm using the MCP Kyvos server. Its arguments are MCP Kyvos server and its endpoint. Similarly, the nomenclature is same for SSE client as well. The SSE client is used for remote communication over the HTTP HTTPS. And once a client sends to a request to the SSE server, the SSE server will start pushing the events to the client. That is a long communication. It's always persisting. So once a communication breaks or there's network failure, so the connection needs to be established again. Again, the package nomenclature is same. The class is MCP server SSE. The MCP server SSE takes a param URL in which you have to pass your SSE server URL. Now, streamable HTTP client is used for the scenarios where you don't want your long sessions to be created. You want it to be stateless. So you have to create a package that is MCP server streamable HTTP from the agents MCP. Again, its nomenclature is same. The params and the URL, it will take MCP server URL. Now we will go through how the authentication happens over the between the MCP client and MCP server. So first of all, there are few steps involved in this. The first step is that we have to uh, do a GET request to a fixed URL that is well-known auth authorization server URL. This is always fixed for any MCP server that is running remotely over the OAuth. Okay. What happens is that it returns the three endpoints, that is registration endpoint that will be used to get the client ID. Then the authorization endpoint that is used to authenticate users, obtain an authorization code. then token endpoint to exchange the auth code we have received in the authorization step. Okay, let me quickly run this cell, and we can see we have fetched the three endpoints. What happens is that I have created a call request over the MCP server URL with well-known auth authorization server, and it has provided me the three endpoints to use. So I have set it in the variables, so I can use them now in the subsequent slides. So let's walk through the first step in this process of registering. After you have fetched all the endpoints, you will have to first do is register your client dynamically to any server that is that is running the MCP server. So first construct the register URL. This will be a post request. The major or the important attributes to send are the redirect URIs. So all the URIs that you support for receiving any callback from the server. Okay, so the server will be sending a client ID to you, so it needs a redirect URL. Okay, the client name, any friendly name for your client app. Token endpoint auth method, it is necessary to be none, as none indicates that it is a public client and it is not going to store any client secret as it is a web application. The grant types are the authorization code and refresh token, which tells us that I'm going to use the authorization code in the bearer and the refresh token for renewing my access tokens. The response type I am expecting from the server is code. So I've constructed a JSON here using the above described attributes. Then we will pass it as a post request to the registration endpoint, and it will fetch me a client ID, which will be setting in a variable client ID. Perfect. So now client has been registered on the server. The next step in this process is to open the browser. So for OAuth to work, as user has to input their username and password on a web browser. So your client has to open a web browser, either it is Chrome, Safari, or Firefox, anything. So what happens is that you take the authorized endpoint. It takes 4 parameters like response type, which is code, which we are expecting. Then the client ID, we just registered, and the redirect URI. So where we want to redirect the user to. Now let me quickly run this and click here. So it has opened a Okta provider screen to me. So it is a dev environment. I'm quickly going to use my colleague's email ID who has set it up. So what happening is that now Okta has validates the credentials, and it has returned access token or code, all those things to the MCP server. Now MCP servers verify, okay, I have received the access token, auth code, and all these session things. The session looks good. Okay, now redirect it to MCP client. The MCP client receives its request on the configured URI that we have configured. So now let me quickly copy this auth code, and now auth code will be used to receive the actual access token, that is a JWT token. Okay. So in this step, we will now access the token endpoint. So now we will constructing the token endpoint. So for that, we have a grant type of authorization token attribute. The code we just copied, the redirect URI, that is again the callback to our client back, okay, to receive the access token and refresh token, the client ID that we have registered with, And in the response, we will have the two things, the access token and refresh token. So let me quickly copy it here. Let me run the cell, and the access token and refresh tokens are generated. So here I have only outputted the partial access token and refresh token. So it is good practice to only not to log any access token, refresh token in your logs on the MCP servers, as well as in your MCP clients. Moving on to the next cell, the MCP server tool integration. As the client is ready, we have the access token and refresh token with our cells. Now this collab has converted into the MCP client, and this MCP client now connect to any MCP server that we have registered with. So we have registered it with the Kyvos MCP server SSE URL. What happening here is that we are connecting using the SSE protocol. The authorization header is set using the bearer access token, and we will see the list of tools that this server offers. The method to get the list of tools is this server.listtools. Okay, so now the server has returned us the 4 tools that are available. So first is the Kyvos list semantic models. List all the semantic models that Kyvos is serving for this user. The Kyvos list semantic model columns. The columns for any specific semantic model is required, then this tool needs to be called with that parameter. Then Kyvos SQL generation prompt. The prompt is needed for any semantic model. Let's say if you have a different kind of models, they may have their own prompt generation logic. The Kyvos execute query after the prompt generation or after the SQL generation, this tool has to be called with the SQL query, and it will return the actual data. So moving on to the next cell, tool calling. So what are we going to do today is that we will try to run some queries on it. So before that, let me explain what an agent is. So I'm using the OpenAI agent framework. So OpenAI agent framework is a core building block in this, and the agent is a large language model configured for your instructions and tools. So what agent does it? It understands your instructions, it executes any task you is asked, or it manages the workflows you create. It is a low level abstraction. Uh, they allow automation workflows. They make easier to orchestrate multiple tools and APIs seamlessly. So what happens is that in traditional uh, way, if you go, you will have to create a HTTP request, then add some tools, JSONs, and your system prompts and user prompts, and then you will be sending it to the LLM. The LLM will be sending a either the response or a tool call. Okay, give me the response for this tool. Then this interaction happens back and forth, and finally LLM returns the response. So what this agent does is wraps all these complexity in a single line of code. It will do all the logic, all the tool calls, all the instructions, or all the tasks you have asked to perform. Once all those tasks are complete, then it will return the final response. So here I have created a small agent, that is analytical agent. What is going to do? I have asked it to create some deliverables, like for any uh, business data, you have to create some actionable insights from that data, and deliverables are data table and a summary. So the agent is written like that. Agent having a name that is again a friendly name. It is not relevant to any of the code, just for tracking. The instructions, what the agent will be going to do. MCP servers. So the array of MCP servers to all which this agent can connect to, or all the tools it can fetch, the model for which I'm using the GPT 4.1. Here I have not passed the OpenAI key, as the OpenAI key is set in the environment in the cell server. Let me quickly run this. The query is show product wise sales. The LLM has identified, okay, I have to run these tools in this order. The first tool called was Kyvos semantic models. Then Kyvos semantic models arguments of the table name retail superstore. Then it asks for the prompt. Then the SQL is generated. And then after firing the SQL over the execute query, the result was sent to the LLM. The LLM has presented a data table as instructed and a summary. So this is how our agent works. So it needed to call 4 tools. It called 4 tools. If it needed to call 3 tools, it will call 3 tools. So that's how the agentic AI works. Now let me quickly demonstrate a small scripted also. Let's say you want to do this thing, but with MCP servers, but also want to run some local tools as well on your client. So what I am doing is I have created a write to file function tool that is defined by @annotation, and the function tool that is provided by the OpenAI agent SDK. Okay, so I have given an instruction, write the given content to a local file called output.md. Contents in the markdown format are written into the file. So the instruction is you are a summary agent, nothing more, nothing less. The agent name, again, the instructions that I have set, the MCP server, the tool that I'm going to use, the model is GPT-4o. So let me quickly run this function tool cell and quickly run this. As you can see, there is no output.md in my directory currently. Once this has done all its work, summary is generated, it will create a file name output.md. Now the output.md is available. Now I can quickly view what my output.md says. Okay, it has given me the summary of the sales, like office supplies is this value, technology is this value, the furniture is this value. So this was how you can make your own agentic AI and apps. I think that has cleared much of your doubts how the agents works. I am now handing over to Mosam for the next part of this. Let me quickly. Yes, Mosam.
Thank you, Prakar, for an insightful coding workshop. I think you pretty much covered all of the important aspects of MCP integration in a Gen AI app. Uh, Finally, I would conclude the session by saying that you can build smarter agents with MCP powered by a semantic intelligence platform like Kyvos that will make your agents more accurate, more cost optimized, and provide better control over answers generated for users' question. Floor is open for Q&A now. Okay, there is one question. Uh, what is the core problem or limitation of the before MCP approach shown in the diagram, and how does MCP aim to solve it? Okay, so the basic problem that MCP is aiming to solve is uh, is standardizing of the fetching of the data from different data sources so that I can use that data in a Gen AI app. So taking an example, let's say if MCP is not there, and if I'm developing a Gen AI app where I need to fetch the data from Kyvos server. Now, instead of focusing on developing the Gen AI app, I would first need to focus on how to fetch the data from Kyvos server. What kind of API does a Kyvos server provide? What kind of authentication mechanism I need to do with the Kyvos server and whatnot, and what kind of protocol it would Does it provide a REST API, or does I need to provide I need to do a socket communication to fetch the data from a Kyvos server? What kind of query that I need to do on a Kyvos semantic model to fetch the data uh, from the Kyvos server. Now, as you have seen in the demo, once I have implemented the Kyvos MCP server, I don't need to worry about all those aspects. I just need to create an instance of MCP server in my GenAI app and provide the URL of Kyvos MCP server where it is running in. All the nitty-gritties of how to fetch the metadata of Kyvos semantic model, how to query a Kyvos semantic model, all those nitty-gritties will be automatically handled in a Kyvos MCP server. My GenAI app will just need to call the appropriate tool and I'll get the required data. So this is the basic problem that MCP is trying to solve. Okay. Uh, so the other question is, what is the major usage of MCP? I think the major usage of MCP is this only, which I answered just now. Uh, can the other question is, can this as an MCP be integrated with Agent Space Google? Prakhar, do you have any idea about this Agent Space Google?
No, Mosam, not right now.
Okay. So Salim, we will get back to you on this over the email. I think you will get the recording of this session, Salim. Now, the other question is, how do you scale your MCP server side? Okay. So I think this question is more on the lines of the scaling of MCP server. So let me again take the example of Kyvos MCP server here. So Kyvos MCP server is developed on Python's Fast API framework. So like you can deploy this MCP server in a containerized environment like Docker, and you can use Kubernetes like tools to auto scale it. But having said that, Kyvos MCP server is a very lightweight MCP server that works on Python ASGI framework, where a single MCP server instance can handle thousands of requests and efficiently. Uh, so and if needed, you can deploy the Kyvos MCP server in a Docker, and then you can do the auto scaling on Kubernetes like frameworks. The other question is, can Kyvos MCP be used in enterprise system? For example, to get SAP HANA data or Azure Synapse data in my AI application? Uh, yes, Kyvos MCP can be used in enterprise system, and you can fetch the data of a SAP HANA or Azure Synapse data in your AI application via Kyvos semantic model. So what you can do, if you can see in the architecture diagram, and let me go back to the architecture diagram. Here, as you can see, the Kyvos semantic model can fetch the data from variety of data sources, including the SAP HANA. So yeah, short answer is yes, Pravesh. You can get the you can use the Kyvos MCP to fetch the enterprise system data via Kyvos semantic model layer. Is Kyvos MCP only used for agentic AI app? Yes, the purpose of MCP is to provide data to the agentic AI or Gen AI app only. The next question is there any free MCP server kind of open sources? The Kyvos MCP server is already open source, Pravesh. Uh, the Kyvos MCP server will connect to the Kyvos. So if you have Kyvos deployed in your organization, or if you have access to the Kyvos server, you can install the Kyvos MCP server much like you install any other Python program using PIP. It is Kyvos MCP server is available on PyPy, so you can install it using UV or PIP and can connect to the Kyvos backend server and can fetch the data of Kyvos semantic model. Okay, the next question is, what safety or sandboxing measures do you have for executing tools? Okay. So again, I assume this is on the lines of MCP server, which executes the tool. Uh, so it is generally a good practice to run the MCP server in a containerized environment where you only provide the needed access control to this application, because MCP servers are running tools. Uh, so they may some MCP servers may run uh, some vulnerable code that can cause harm to the system. So it is always advisable to run in a isolated and containerized environment. Hence it is as if you have seen in the presentation as well, we have mentioned that you should only use the stdio transport mode for the local developments and for demo and POC purpose, and not for the production deployment. For production deployment, you should always run the MCP server in a containerized environment and in an isolated environment where you have limited access control. For those who have Microsoft Copilot license, how can we make use of this server? So if Microsoft Copilot supports integration with the MCP, you can still uh, integrate Kyvos MCP server, or for that matter, any other MCP server with the Microsoft Copilot, and can fetch the data from the relevant data source. For this, the Microsoft Copilot should support the MCP integration. The other question is, what is the advantage of Kyvos MCP server compared to Oracle SQL MCP server? Okay, so there is no direct comparison between Kyvos MCP server and Oracle MCP server. The Oracle MCP server is used to fetch the data from Oracle SQL database or warehouse, while the Kyvos MCP server can be used to fetch the data and metadata from the Kyvos semantic model. Now, if you are using the Kyvos semantic model and using Kyvos MCP server to fetch the data of Kyvos semantic model and metadata, as I mentioned, this will enable your agents to be more accurate, uh, uh, will provide better control over answers generated for the user's question. This is because of Kyvos' semantic intelligence layer uh, that gives the extra semantics or extra context to the LLM for generating the better answers for your questions. All right. Thank you for joining the session. Uh, we are closing the session now. For more information, uh, you can visit our website kyvos.io, or you can get in touch with our sales team. Thank you, everyone.